If you can just see the chat box, there are a few links I have just pasted. I have pasted just now, wherein first link will be of syllabus link. By clicking on this link, you can just have access of your syllabus, your specific science subject. By clicking on this particular link, you can make a payment to just buy this course. Okay. For your feedback, you have to just click on this particular link. For all batch details, you have to just click on this particular link to just understand the details of your batch. And in case you have any query related to your batch, your timings or anything, you are feel free to interact on this mail, which is support@olympiadscience.com, or you can just WhatsApp on these respective numbers also. Okay. So in case you find any network glitch, you can join us on Facebook Live. Okay, because after this, we're going to go live on Facebook also. In case you're not able to join us on Zoom, you can just watch us on live on Facebook. Okay. So we have Miss Usha Banerjee, ma'am. She's a wonderful mentor. She'll be going to give you the very visual clarity about your specific subject. Then we do have Aishwarya ma'am also. She'll also a wonderful mentor who'll be going to give you the better clarity about your biology with a great conceptual understanding. Okay, so I'll not take much time. First, I'll hand over to Usha ma'am. Usha ma'am, all over to you.
Yeah, hello everybody. Good evening. And it's nice to see so many children joining in. Okay, good evening. I'm Dr. Usha Banerjee. I have got a PhD in computer science. I'm in academics and academic institutions for more than 20 years now. And I'm associated with Olympiad Success for a number of years now. And most of my students have started with class 6 and now they are in class 10 of many batches. And I'll be taking your physics and chemistry classes. And as all of you are in the 9th class or in the 9th grade, this is like your pre-board year, right? So, and surprisingly, in case of CBSE, the syllabus of class 9th is is the most vast syllabus. That way, 10th is way simpler. And in class 9th, also we expect that your concepts have absolute clarity. So my teaching typically focuses on clarifying the concepts. And also definitely a lot of numerical questions. Physics is entirely numerical for you. And chemistry also is numerical for you. And that's the reason understanding of the concepts is really important. And I look forward to taking the demo and also, actually in the live classes, because unfortunately now in the demo, you all are on mute, but very soon I'll get to see you all in the real live classes. Over to you, Pooja.
Thank you so much, Usha ma'am. Wonderful to hear you that. Now I am just hand over to Aishwarya ma'am to just provide a brief introduction about herself to students. All over to you, Aishwarya ma'am.
Thank you, Pooja ma'am. Hi, everyone. I hope I'm audible to all of you. And I can only see, three of you on camera. I hope everybody else could also switch on their cameras. It would be lovely to see everyone. Nevertheless, I'm Aishwarya. I'm going to be taking bio for you for this year. All right. And like Usha ma'am said, class 9th will form the basis for your higher grades. So if you're planning to take science, specifically PCB or so for physics and chemistry, of course, Usha ma'am will take care. Rest bio I'll be taking for you, and all I want from you is to be as interactive as possible, so that you don't get bored in class, because normally bio is very theoretical. We don't have any numericals here, so it just tends to get boring after a couple of minutes, right? Other than that, a little bit about me. So I'm from Delhi. I have an MPhil in botany, and I'm currently pursuing my PhD in botany. And I have been taking competitive exams classes for almost 5 years now. And I've been associated with Olympiad Success for the past 2.5 years. So that's it. I hope we have a great demo today, and we'll have fun in the regular classes. Thank you.
Thank you so much, Aishwarya ma'am. Okay, so as Aishwarya ma'am told just now, that we need to make this class more interactive, right? For that, what all you need to follow the first step. Your camera should be on. I can see Sujal camera is on, Tanrika camera is on, Shloka camera is on, Ritu camera is on, but others who all are there in the demo, their cameras are off. So in this way, we'll not be going to keep ourselves interactive. You'll not be going to interact with the mentor. If she'll not be able to see your faces, how it will be going to go about. So I request everybody once again to just turn on the cameras. Okay. Nice to see you, Aditya. Sain, Dipanshi, Ishita, Tanmay, Sgarang, Roy. Turn on the camera.
Sarang, he was my student.
Sarang.
So, yeah.
Okay. Okay. So I'm going to share a PPT with you, okay, which will be going to provide you the information. Just a moment, and then we are good to go. Hope my screen is visible to everybody.
Yes.
I know that we are in demo of grade 9 science, right? So Olympiad Success is a platform which provides India's largest online preparation platform for Olympiad examinations, which concludes 8 courses. School Plus program includes the subjects mathematics, English, science, logical reasoning, communication, spoken and written, Vedic maths, and coding. So it provides a one-on-one online CBSE, ICSE, IGCSE, and IB classes for grades 2 to 12. So it provides one-on-one preparation classes for International Mathematics Olympiad as well, which includes SESMOs, SEMO, HKIMO, TIMO, Math Counts, US Common Core Math Competition, Math Kangaroo, and PRMO. These all are rank holders on the screen in year 2021 and 22. So your picture will also come soon in case you just prepare well. So go ahead with that and definitely score well and come up with the good marks. So these all are the details for your session, which includes group session will be around 20 students delivered through our tutors via Zoom. So session will be twice a week. Days will be Wednesday and Friday. Timings will be 6:30 till 7:45 with 5 minutes of break. Okay, so total session will be of 75 minutes. The session includes a mix of theory practice questions, doubt sessions, and discussion on previous year papers. Students will get reading material and practice questions, which will be available on the dashboard of Olympiad Success. Soon I'm going to give you a dashboard tour about that. Students will get a free access to Olympiad Success platform to practice topic-wise mock test for both maths and reasoning to a logical reasoning constitutes 10 to 15% of the questions. The objective of these sessions is to provide introduction to the entire curriculum and give sufficient headway to the student compared to their peers. So all these relevant links have been pasted in the chat box earlier also and will again pasted. No need to worry for the same. So this particular link is for syllabus. You can just click on this and you can check your syllabus for your respective subject. Fees can be made on clicking on this particular link, which is the fees is 13,356 rupees for 60 session course. The fees includes online classes, daily reading notes, and exercises, practice for previous year papers, access to Olympiad's platform for mathematics plus logical reasoning. So what all you need for these classes? Just a laptop or desktop with good internet speed, with good camera for the better clarity of the picture, and headphones for the better audio clarity. Make sure that you spare every day 2 hours extra. As you know, Olympiad examinations are a little tougher than your other main exams, regular school exams. So make sure that you spare 2 hours extra along with the studies for the preparation. So our regular classes are going to start from Wednesday, that is 10th of April. Hope details are clear to everybody. Now I'm going to take you through the dashboard, when you'll get to know about your reading deal, your question papers, and all these details. What you have to enter is you have to just enter this olympiadscience.com URL, and you have to just enter your correct user details. Who all are registered with us, they'll get their user details to access all these materials. Make sure that you enter your correct user details, otherwise you will not be able to log in. Once you are logged in, you will get this personal details on your screen where you just need to check these details, whether these are correct. If there is any error, you just need to rectify it over there and you can click on update button over there. Once you're done with this, you have to move on live classes. By clicking on live classes, you'll get to know that from which subject you have to just see the material. Okay, so after clicking on live classes, you have to select your specific subject and specific topic also, for which specific topic you want to see the stuff. So here is a schedule. Schedule will give you the clarity in which session you're going to cover which specific topic, okay? So that you should not miss any of the session. So each and every PDF is downloadable. For that, you have to just click it over here, click over here to download the PDF. Here is a holiday calendar. In holiday calendar, you'll get to know on which festival we do have offs, okay? So that you should not miss any of the other class. Reading material will be there for you. You have to just click it over here and you can just see your reading material for your specific topic. Each and every topic is having a reading material. You just need to select your subject and your topic to just have access for the same. So each and every PDF is downloadable, as I told you earlier also. You have to just click it over here, click here to download the PDF to just download it, and you can keep it saved in your device also, that in case you want to check it offline, you can do that. So for this question answers, you have to just click it over here. This is a question paper. You can just download this paper, take out the printout, solve it, and then check your answer. Don't download your answer keys parallelly, because in this way you will get curious to check your answers parallelly while attempting the question paper. All right, so this is the question paper. You can see there are so many questions for your practice. So here is the answer key for the same paper. You can just check your answers once you're done with your paper. Which question you have done correct and which you have done wrong, that you need more practice in that specific question. Okay. So goes for set 2. This is it. Okay. And this is answer key. This is your answer key. Okay. So in live classes, you can check your question papers, your answer keys, your reading material, your schedule, and your holiday calendar. Okay. All just you have to do is you have to just select your subject and your topic. So after this, you have to just click on worksheet. For worksheet, that is additional practice for you. You have to select your subject again, for which specific subject you want to see your worksheets. And you can select the number also, how many you want to see. Okay, so this is the first paper. I will show you how you can attempt the worksheet. So for temptation, you have to just click on take exam. While clicking on take exam, you'll get this general instructions on your screen. After these instructions, you have to just read these instructions carefully, that you should not commit any mistake while attempting your worksheet. So after that, you have to just click on take start worksheet. So you can see there's so many questions in your worksheet, 50 questions. So attempt each and every question carefully, that you should not commit any mistake while attempting. Okay, so you're done with the question 1. You have to move on question 2. For that, you have to just click on next button. So keep on moving ahead while clicking on next button once you're done with questions. Okay. Once you're done with all the 50 questions, you have to submit this worksheet. For that purpose, you have to just click on finish button. While clicking on finish button, you will get these 2 buttons wherein you have to click yes, I've reviewed all the questions. Make sure that you should review all the questions beforehand, the way we give our papers to our examiner in the examination. Okay. So in case you find any error, you can just rectify it before submitting, because after submitting, you'll not be able to make any of the changes. Yes, I've reviewed all the questions. Make sure that you submit your worksheet, otherwise you will not be able to see your performance also. Okay. This is a feedback page you want to give there and then. You are okay with that, you can give, otherwise you can click on later. Once you're done, now you want to see the performance. For that, you have to just click on performance button, which is right after this worksheet icon. So while clicking on performance button, you have to just select your specific subject, for which subject you want to see the worksheet. I select science. I've attempted this worksheet just now. You can see the date 4. So I'll click on view button to see the performance, how I performed. I've attempted 2 questions. 1 is correct, 1 is wrong, right? So make sure whenever you are attempting the worksheet, you should be concentrating. So click on review button to see which answer is correct, which is wrong. Again, feedback page. Okay, so this is all about dashboard. In live classes, you'll get your reading material, your question papers, your schedule, your holiday calendar. In worksheet, you'll get your practice worksheets, your performance, you'll get your performance, how you have done the worksheet. Okay, so that was all about dashboard tour. You can log out and we are good. So that was all about dashboard. If anybody is having any query related to that, please drop it in the chat box. I'll be happy to answer your queries. And I'll repeat once again, please turn on your cameras. It doesn't look good that you all are sitting with the cameras off. Let's make this class more interactive and engaging while keeping your cameras on. Already we are meeting online, so it doesn't look nice that 50% of students are sitting with the cameras on. Okay, so anybody is having any query related to the dashboard, drop it in the chat box. I'll answer your queries, or all okay. If all okay, then show me a thumbs up. Nobody is having any doubt. Then I'll ask the questions. Let me see whether you have seen the pretty carefully or not, because I can see the faces. You people were there in the mathematics demo also yesterday, right? She was there. I remembered. Okay. Everybody's clear with the dashboard. I think you people have seen the dashboard yesterday also. Okay. Tell me, what are the class days? What are the class days? No, Sujal, it's not Monday, Wednesday, Friday. It's Wednesday, Friday. You have not seen the PPT carefully? That's why we say stay attentive, okay? So the class days are Wednesday and Friday, and timings will be 6:30 p.m. to 7:45 p.m. with 5 minutes of break. Okay. So let me paste few chat links in the chat box, and if nobody is having any doubt, and then we are good to go with the demo, I guess. Show me a thumbs up on the screen if everybody's okay. Nobody's having any doubt. Then we'll move ahead with the demo. I'll hand over to your mentors. I think everybody's okay. Ushma, all over to you.
Okay. Somebody had a question where.
Yeah.
Okay, yeah.
Jay Shri, ma'am, only for 9th class.
Yeah.
Yes, Jay Shri, this is for 9th class. This demo is for 9th grade. Hope your question is answered.
Okay, let's start off with the demo then. So today I've decided to give because the time is short, a small demo on one of a very important topic. Is there any other day? Sarang has a question. Pooja, Sarang is asking a question. Okay, anyway, Sarang will answer your question in some time. And definitely you can contact the Olympiad success team, if you have more questions and all that, it's completely okay. Okay. So I have chosen the topic of motion for this demo. Sarang, as of now, just to clarify your question, the classes are, as of today, the classes are on Wednesday and Friday from 6:30 to 7:45. And how we will do is that we will start off with the physics and chemistry part first, and then once that is finished, the biology part will be done. Okay. Now I chose the topic of motion because first of all, motion. I know you have studied motion in your class 6 and in your 7th grade also, and I can see many of you were my students in your earlier grades also. In 7th and 8th, you were my students. So you can ask me why the same topic of motion in class 9th also, right? Now in class 9, the concepts don't change. The concepts remains the same, but the depth in which we do the questions, the numerical questions, all will be numericals. And the numericals will be totally, on a much difficult level than what you have done in your earlier classes. I emphasize that my objective will be to explain the concepts well. So let's start off, right? Now, whenever we talk about motion, we have, two kind of things here. We have rest and we have motion. So when an object is at rest, so an object is at rest if there is no change in the position. Okay, and with respect to time. So whenever we are talking of motion, time is a very important factor. For example, now it is 6:51 p.m. in India, and I am sitting in a chair. Once the class gets over at 7:45, I'll get up and have a cup of tea or something. So then from 6:30 to 7:45, my body is at rest, right? And similarly, motion is if the position changes with respect to time. So when we talk about motion, the reference frame becomes very important. Reference frame, as in reference frame might be time, reference frame might be a position also. So it might be the position with respect to the surroundings. So now I am in my house at 6:30, at 8 o'clock, I might go out for a walk, right? So the position or the reference frame plays a very important role. Because this is a demo class, I know all of you will be on mute. In case you have questions, just type it in the chat window. I'll try my best to answer it, right? In the real classes, in the live classes, anyway, my classes are very interactive and you can not only, remain unmuted, but also you can write whatever, annotate on the screen also. It's completely okay. So as I was saying, the reference point and the reference frame play a very important role in motion, right? So whenever we describe an object in motion or at rest, we need to have some reference. And this example is a very good example of, understanding this. So suppose you're sitting in a school bus or any other bus with your friends in the school bus or your co-passengers in the bus. So all the other children sitting in the bus with you are at rest with respect to you. But for a person standing outside the bus on the road, all of you are in motion. So the reference frame plays a very important point here. So when we describe motion, we have two concepts of distance and we have displacement, right? I know you have done all this in your earlier classes. This is just like, strengthening your concepts as I say. So distance is nothing but the actual path covered or the actual path traversed by a body. It is a scalar quantity. What is a scalar quantity? Anybody? What is a scalar quantity? So a scalar quantity, correct. It has only magnitude. Absolutely correct, Ishi. Magnitude means numerical value. So a scalar quantity has only magnitude, and the opposite is a vector quantity. It has both magnitude and direction. Correct, Tanirika. I will take some time to learn up your names. Definitely in the live classes, yes. The SI unit of distance is meter. Meter is the SI unit. What is the SI unit? International System of Units. And the CGS unit of distance is centimeter, right? On the other hand, displacement, it is the shortest distance from the starting position to the ending point, or the starting point to the ending point, whatever you say. Displacement is a vector quantity. Vector means direction is also important, or it requires, the displacement requires both magnitude and direction, correct. And the SI unit of displacement, like length, like distance, this is also meter. So the difference between distance and displacement essentially is the difference, the fact that this is a scalar quantity and this is a vector quantity. Not only that, displacement is the shortest distance. Okay, I will write one sentence which will explain everything. Displacement is always less than or equal to distance. It can never be greater than distance. Okay, so displacement can never be greater than distance. Okay, done? Clear till here? Now I'll give you another, very simple, example, which I say always. Suppose this is your home. Suppose this is your school. If you go to school by your own car, your father drives you or mother drives you, or you, cycle down to school or you walk down to school, pakka you will take this path, right? Because this is the, shortest path. But suppose I tell that you go by school bus, okay? So but you go by school bus, the bus, this is the home of your friend, say home 2, and then this is the home. Or let's take only one of your friend, sorry about my sneezing, and then your bus goes to the school. So this is the path of the bus. So the shortest distance is this dotted line. So let's call it ABC. So AC is the shortest distance, which is my displacement, while AB plus BC is my distance from your home to school. And here also from home to school, right? So distance is the actual path covered by the bus and displacement is the shortest path covered by the bus. Clear? Now, in case of, normal, paths, this is great. Now let's take an example of a circular, football ground or a ground near your house. This is the center. Let's call this O. You start your morning walk here at this point. Let's call point A. And you're walking all around the park to the point A again. So the total distance covered will be how much? Anybody? Total distance covered? How much? Will be the circumference of the circular path. Absolutely correct, Ishi. Yeah. So that will be 2 pi r, where r is the radius of the circle and pi is 22/7. And what will be the displacement covered of your displacement? Will be 0. So a very important fact again. So whenever or if a body means, you are a body, an apple is a body, a football is a body. So whenever we do physics, we talk about body or an object. If a body comes back to its starting position after traversing or traveling some distance, its displacement is equal to 0. So suppose you start from the point A, you go to the point B like this. And then you're again coming back from B to A. So A to B and B to A, displacement will be 0. So always when you are coming back to the original position, after traveling some distance, the displacement covered will be 0. Clear? Understood? So this is applicable whether circular path, straight path, rectangular path, whatever path it is. Okay. So while teaching the concepts, I'll focus a lot about small tips and tricks which will help. As I told you from this chapter, from physics, 99% you get only numerical questions. Okay. In the Olympiads, in the school, you will be getting, normal, subjective questions also, but Olympiads is only numerical questions. So definitely for solving the numerical questions, your concepts have to be absolutely clear. Clear till here? And definitely I'll be using a lot of board work and, everything has to be explained. Right? Okay. Any questions, any doubts, feel free to just drop a message. I will explain or answer your question. Now coming to the concept of uniform motion. And non-uniform motion. So uniform motion is when a body travels equal distances in equal intervals of time. I will give you an example of this. Suppose A to B, B to C, C to D, and D to E. Suppose this is 1 meter, 1 meter, 1 meter, 1 meter. And a bus or a train, or you are moving from A to E. Say, this is the path. Say this time is, say, 5 seconds. I'm just taking random examples, 5 seconds, 5 seconds. So equal distances the object is traveling in equal intervals of time. This is uniform motions example. If you draw a graph or if you plot a graph, this is the x-axis, origin, and y-axis. Say this is distance. I plot it in meters, and this is time in seconds. The graph that you draw will be a straight line passing through the origin. So this is a graph of uniform motion. Clear? So by looking at the graph, you should be able to identify whether it is uniform motion or whether it is non-uniform motion. And definitely we have numericals on this. We'll do it when the actual classes happen, right? On the other hand, non-uniform motion is when a body travels unequal distances in equal intervals of time. Right, so how it happens? Say unequal distances A to B, okay, and then we have B to C, D, and say E is somewhere here. The time is the same. So suppose this is say 5 meter, this is 1 meter, this is 2 meter, this is 3 meter, and the time required for all is the same. So I'm highlighting again for your convenience, unequal distances in equal intervals of time. If you plot a graph of distance versus time, so whenever we plot the graph now, whatever is in the y-axis, we will refer to is first. So this is a distance time graph. So the distance time graph for non-uniform motion will be something like this. And this is the origin O. So by looking at the graph, you should be able to tell, first of all, you should be able to even calculate the speed or the average speed. I'll show you that in the classes. And you should be able to tell whether it's uniform motion or non-uniform motion. Right? Any questions, doubts, please ask freely, not an issue. I will clarify everything. Okay. Ritu has typed in a question. In uniform motion, it must only pass through the origin, not necessarily. If the body has any initial velocity, Ritu, then it will not pass through the origin. It will start. So to answer your question, Ritu, I'm just changing my color. So if a body is in uniform motion, but with some initial velocity, let's say this is the initial velocity, I call it U, okay? So therefore, the object, the uniform motion graph will be like this. So this point U, I'm writing it down. This is the initial position of the body. So it's not from 0, 0, but it will be from, what about equal distances and unequal intervals of time? Yeah, that doesn't happen. That is also non-uniform motion. Okay, is she okay? So yes, it is completely possible that the body has some initial velocity and then, it, moves forward. Absolutely possible. Right? Few concepts which you really have to be very, very clear. Speed. Speed is the rate of change of distance. Or speed is equal to distance by time. Correct, Tishi. Now, small tip. Whenever there is rate of change, now, this means that the numerator will be time. Distance is a scalar quantity. Numerator means this is the, denominator, denominator will be time. So distance is the numerator and time is the denominator. So whenever I define anything as rate of change of something, the rate of change of something means the denominator will be time. Now, distance is a scalar quantity. So therefore, speed will also be a scalar quantity. And what is the SI unit, international system of units for speed? Meter per second. But we also use kilometer per hour. So we will convert kilometer per hour to meter per second. We use this a lot. So 1 kilometer per hour is nothing but 1000 by 3600 meter per second, which many children do shortcut 5 by 18. 1000 by 3600 is 5 by 18. So many children straightforward put 5/18. That's also okay. Okay. Understood till now? Okay. I know I'm rushing, but actually my time is very limited. I have to give Aishwarya some time also, right? Now, this you are done in your class 6, 7, 8, I know. In class 9, we will do average speed. So average speed is total distance divided by the total time. We'll do loads of numericals in this. Yeah. So we'll do loads of numericals and I'll show you how to do it and how to calculate it, etc. Velocity is the second parameter that we will use. Rate of change of displacement. Or velocity is equal to, correct Samira, displacement by time. Displacement is a vector quantity. So therefore, velocity is also a vector quantity and the unit is meter per second. Now, one small thing which you haven't done till now. So velocity can be different if speed is different or if direction is different. So if an object is moving in a circular path with constant speed, it will have a different velocity. So in a circular path, speed might be constant or uniform, whereas velocity will be different. Why? Because at every point of the circular path, the direction of the object is changing. Okay. So that is the reason the velocity will be different at every point. Right? I never read through PPTs, you know, these are things which you have to understand. It's all there in the PPT, but I don't want to just simply read through it. Okay, when we do the classes, all this takes a lot of time because we'll do loads of numericals. And when I do numericals, I will not only do the one of the Lakshmi Singh's book. Typically in class 9, I will advise for those in CBSE board, please follow the Lakshmi Singh's book for your school. Okay. Now, we have the, ma'am, could you repeat why speed is the same? Yes, Tanirika, right? Tanirika, let's say an object is in a circular path. Say a ball is in a circular path, okay? So the ball might have uniform speed, correct, Sujal? But velocity will change or will be different at each point. And why is it so? Since the direction of motion of the ball changes at each point. So here the ball is here. When it moves to this point, the direction has changed, so on and so forth. So because there is a change in direction, the velocity of the ball will also continuously change. Yeah, Sujal, that's correct. The Lakshmi Singh and the Manjit Kaur's book, right? Okay. So understand something, speed and velocity are not always same. Okay, many students just mix up speed and velocity. Absolutely not. Usually when we do, you know, numericals or derivation, we'll do the derivation of all the laws here. Initial velocity is referred to as small u. Final velocity is referred to as small v all across the world. Time is referred to as small t. So we have a concept of average velocity, which is nothing but initial velocity plus final velocity divided by 2. One, you know, very important fact, the average velocity or the average speed of a moving body can never be zero. But the average velocity of a body can be zero. Can you tell me why? Can anybody tell me why? I wrote the average speed of a moving body can never be zero, but the average velocity of a moving body can be zero. I want you to tell me why. Anybody? Try now. I know it's difficult when you're on mute, but at least type it in the chat window. So basically, I'll just, don't know, please explain. Yeah, I will explain. I'm just rubbing this part here. I want to keep that sentence. Yeah, Ishi, that's correct. So basically, the explanation is that, so for a moving body, displacement, yeah, correct, can be zero. So when does that happen? When a body returns to its original location, or let's say original starting point. But distance can never be zero. So average speed can never be zero. Yeah, I'm seeing your answers in the chat window. Absolutely correct. Ishi, Samaira, both of you are correct. So because an object, in case of velocity, the displacement of a body can be very easily zero when the object or the body returns to its starting position after its motion. But it is impossible for the distance to be zero, and therefore average speed can never be zero. Okay, these are typical MCQ type questions which come very often in your school exams. Olympiad will not give such easy questions. That is for true. Right. Now we'll do a lot of questions once we start with the live classes, numerical questions. I really don't have time. I have to give off the demo to Aishwarya in 3 or 4 minutes. So I don't have time to really go through any numerical questions. But definitely we will do loads of questions in this. So these are the differences between distance and displacement. I don't want to read through it. So displacement can also be negative, by the way, and that depends upon the reference point. The unit of both, SI unit of both of them is meter. Correct. These are examples. I know you have done scalar and vector. When we start the classes, I'll also explain it once again. So scalar is a quantity which requires only magnitude. Magnitude means a numerical value. Vector requires magnitude and direction. These are the systems of units. Why do we take only length, mass, and time? So length, mass, and time are known as the fundamental units. Fundamental physical quantities. This is a topic of physics, right? So physics is the study of physical quantities. So length, mass, and time are the only three fundamental physical quantities. So SI unit means here foot, pound, and second. Foot, pound, and second is used in the UK, United Kingdom even now. And today, in India, we use foot, pound, and second. The unit system of units possibly only in bakeries. When you go to buy a cake, you say a 1 pound cake, right? It's obsolete. CGS is centimeter, gram, second. And MKS unit is what we normally call as the International System of Units or the SI system. Whenever I teach something, I will tell you the SI unit or the MKS unit and the CGS unit also. Okay. So, and I'll show you the conversion of both the units also. Right. So don't worry if I think I'm just rushing through. But in the live classes, we'll focus a lot on this. This is what I was telling you, definition of speed. All these are basic concepts. You'll need this even in your 11th and 12th. So your concepts should be absolutely clear. Acceleration is nothing but the rate of change of velocity. So acceleration is given by final velocity by minus initial velocity by time. And from here itself, so or I can write this v minus u, or v is equal to u plus at. And this is nothing but the first equation of motion. I will derive all the equations of motion for you in the classes. So simple. U is always taken as the initial velocity all across the world. V is the final velocity. The unit of acceleration is meter per second square, and acceleration is a vector quantity. Okay, I have to give off, I have to close the demo now and give it off to Aishwarya. So I look forward to having you in the live classes. And now I will request Aishwarya to, do the demo of the biology part. Thank you, everybody.
Thank you, ma'am. All right. I think we can start with the bio demo. Let me just share my screen with you guys. I hope my screen is visible to everyone. Okay, so for today's demo, we are going to talk about the topic cell. All right, now cell is something again that you've done in previous classes, but here we will go into detail of all the organelles and each and every the function of each and every organ, right? So can you tell me, can somebody define cell for me? What is a cell? How do you define it? This is something we've done before. So what is a cell? Can you all put it in the chat box? Okay, correct, Ritu. It's the basic unit of all living organism. All right. Yes, it is the fundamental unit which supports life. Anything else? Anyone else wants to add something to it? No? Or are you guys already tired with physics and chem demo? Okay. Yes, that's what I was looking for. Correct. Cell is the structural and functional unit of life. Okay. So when we say structural and functional unit of life, what do we mean? We mean that structure-wise also it's the smallest unit. Okay, there is nothing smaller than this. Okay, you cannot divide it further. And functionally, this smallest unit can function as a whole organism on its own. That means all the metabolic pathways that are present inside a living organism can be performed by this cell alone. Okay, so for example, let's say our body is undergoing digestion, excretion, reproduction, right? As a whole, the body is doing this. The same things the cell can also do it alone. Okay, it has all the mechanism inside. That is why it is known as a structural and functional unit of life. All right, now before we move on to what exactly is going inside the cell and what are the organelles or what are the parts of the cell, just an overview of how cells are divided or how cells are classified. So normally cells are of different types based on different parts. First, it's organization. So what kind of cellular organization is present inside the cell? So we have two types of cells. We have prokaryotic cell. Yes. And we have eukaryotic cell. Quickly define what is eukaryotic, prokaryotic. Let's start with prokaryotic. Can anyone tell me what is prokaryotic? Or give me an example of a prokaryotic cell, anyone? Example you can give me, if not definition, quickly. It's okay even if you're wrong. We're all here to learn. It's fine. Just whatever comes to your mind when you hear prokaryotic, eukaryotic, bacteria. Correct, Ritu. Very good. What about eukaryotic cells? Any eukaryotic cell? Yes, Saram. Prokaryotic is a cell which does not have a well-defined nucleus. Samira, good. Okay, correct. Yes, Ritu. Fungi is a eukaryotic cell. Correct. So pro means primitive. Okay. U means true. All right. Karyon or karyotic means nucleus. So prokaryotic organisms have a primitive nucleus. That means they do not have a well-defined nucleus, and their nucleus does not have a nuclear membrane. So their genetic material is usually free-floating in the cytoplasm. Okay. Eukaryotic, on the other hand, U means true. Anywhere, wherever the term U comes in biology, it means true. So true nucleus, that means it has a well-defined nucleus with a nuclear envelope or a nuclear membrane, and the genetic material or the DNA will be present inside that. Okay. Examples of a prokaryotic cell, like Ritu said, was bacteria. And eukaryotic cells, we have animals, fungi, plants, we are all eukaryotic. Okay. Another thing about prokaryotic cells are that prokaryotic organisms are always unicellular. Okay. Eukaryotes, on the other hand, can be both unicellular and multicellular. So this classification of cell was based upon the cellular organization inside the cell. The second kind of classification that we have is this only, based on the number of cells, unicellular cells or multicellular cells. That means if any organism is just made up of one cell, we call it a unicellular organism. And if organisms are made up of more than one cell, we call it a multicellular. Correct, Samara. Yeast is the only unicellular fungi. So a couple of examples of eukaryotic organisms which are unicellular, we have amoeba, we have yeast, okay, euglena, and multicellular, your plants, animals, mammals, whatever. All of us are multicellular organisms. Okay. So far, any doubt, anyone? In this classification? Yes, no, don't know. Okay. So cells, we know cells will make up your tissues. Tissues will make up organs. Organs will make up the organ system. And the organ system will make the body. Right? So certain organisms are cellular organizations, some have tissue level organizations, some have a couple of organs, some have organ system organizations. So different organisms have different levels of organization when it comes to the kind of structure that they have present inside them. All right. Now, when we are talking about cells, cells have different types of structures. So these are the structures. Now we'll do this in detail when we come to regular classes. Here I'm going to talk to you about the cell theory. All right. So when cells were discovered, what happened was the cells was discovered by Robert Hooke. Okay, so Robert Hooke was looking at the cork cells or the bark cells of the plants. All right. And during that time, there were no, we didn't have a lot of advanced microscopes. So we had a normal, very basic microscope. So he took these bark cells and he observed them under the microscope. So what he saw was he could just see these outlines, okay, which looked something like this. And inside it was empty. Why? Because the bark cells are dead cells. Okay, so only thing he could see were these compartments. Now, he had recently visited a monastery. So what he could see was that these looked like rooms in which the monks were staying. Okay, and those rooms were known as cells. So he named them cells. All right, so he could not see anything inside. The living cell was then first observed by Anton von Leeuwenhoek. So Leeuwenhoek was not a scientist. He was actually working on different microscopes. He was much more interested in, in creating advanced microscopes. So he was creating these different microscopes and he was testing them. And he was a cloth merchant and he was looking at pieces of cloth. He was just looking at anything and everything under the microscope to see if the microscope is working. So what he saw was that there were different kinds of cells that he could see, or different kinds of shapes and sizes of cells that he could see. So the first time he saw cells were in the pond water. So he took some pond water and he just placed it under the microscope. So he saw substances moving around in water. Since things were moving around, he named them animal cues because he saw them moving. Okay. So what he discovered was, or what he saw exactly, were nothing but bacterial cells or certain fungal cells. And they were made up of something more that was present inside the cell. So he could see the components of the cell organelles as well. So the living cells were first seen by Leeuwenhoek. Okay. Then came a number of couple of more scientists that we'll discuss in the regular classes. Now coming to the cell theory. So when cell was discovered and each and every, all of people were studying about cells or trying to find out what exactly is present inside the cell, there were two scientists now. One was a botanist and one was a zoologist. So we had Schleiden and Schwann. Okay. Schwann was a zoologist and Schleiden was a botanist. So individually, they were studying animal cells and plant cells respectively. So Schwann was working on animal cells, Schleiden was working on plant cells. And what they figured out was that both of them had the same kind of organelles inside the cell. So plants also had plasma membrane and cytoplasm and all the organelles like mitochondria and ER and all those things. Whereas the animal cells also had the same things. Okay, so they came up with this cell theory. So cell theory has three basic postulates. First, that every living organism is made up of cells. So cell is the basic unit of living organism. That is their first postulate. Second thing is that all organisms or all living organisms that we have are either made up of cells or products of cells. That means they have the plasma membrane, they will have the cytoplasm, they will have mitochondria and everything. And the third postulate is that all cells arise from pre-existing cells. Now, this third postulate of all cells arise from pre-existing cell was given by another scientist called Rudolf Virchow. Okay, so Rudolf Virchow is also credited by giving the cell theory. So three of them, Virchow, Schwann, and Schleiden, they all have given the cell theory. Okay, cell theory is very important. At least one question will come on cell theory asking you what is the three postulates, or what do you mean, or what do you understand by it, or a situational based question can come. Okay, now we can see that cells are made up of different cells are of different shapes and sizes. So you see here, this is a spindle shaped cell, this is a disc shaped cell, we have globular shaped cells, oval, elongated. So these cells are of different shapes. However, if you look inside them, the organelles will be same only. So they can vary in shape and size. They can also vary in the kind of structure they have externally. But internally, all the cells will be same in terms of having the same kind of organelles. So we can have a very large cell, for example, your ostrich egg, that's the largest animal cell that we know of. Okay. You can have a very long cell, for example, the nerve cell, it is almost 2 meters long. And we can have tiniest cells, small little cells that are not visible to the naked eye as well. So cells can vary. Can someone tell me which is the smallest living cell that we know of? Smallest living cell. Not bacteria. There's something else. It's a prokaryotic cell only, but it's specific. Anyone else wants to give it a try? It is a prokaryotic cell, the smallest living cell that we know of. Largest cell, I already told you, is an ostrich egg. So it's this big and Mycobacterium. No, that's you're close, but it's not a bacteria, like I said. It's a prokaryotic cell. Yes, it's a mycoplasma. Very good. It's a, no worries. It's a mycoplasma. So mycoplasma is a prokaryotic cell. Okay. And it is the smallest living cell that we know of. The difference between a mycoplasma and the bacterial cell is that mycoplasma does not have a cell wall. Okay. Any doubts so far, anyone? No? Also, those of you who have your videos off, please switch on your videos. Okay. So here are certain characteristics of prokaryotic cells and eukaryotic cells that they have mentioned. So prokaryotic cell, like I said, pro means primitive. So it's the oldest cell type. It is small, it is simple, it lacks a proper nucleus. And membrane-bound organelles are also absent, and it is always single-celled. So membrane-bound organelles, for example, like your mitochondria, your endoplasmic reticulum, your chloroplast, everything is absent. And examples are bacteria and blue-green algae. Blue-green algae is also bacteria, but it can undergo photosynthesis, hence it's known as an algae, but it is also called cyanobacteria. So cyanobacteria and blue-green algae mean the same thing. Again, I'm repeating myself. Though algae is written here, this is not an algae because algae is a plant and algae will be a eukaryotic organism. But this has a green pigment and it can undergo photosynthesis. So hence we call it blue-green algae. But correct name is cyanobacteria. Coming to eukaryotes, eukaryotes are more advanced. So they are evolved from prokaryotes. They have a much more complex structure. They have a nuclei. They have all the membrane-bound organelles. They can be single-celled and multicellular, and examples are fungi, protozoans, plants, and animals. Okay, this I've already told you. Similarities are that they both have DNA, they both have ribosomes, they have a cytoplasm, and they have a plasma membrane. So when we come to regular class and I start talking about cell organelles, what I'm going to do is one by one, I'll talk about the cell organelles, and I'll tell you whether or not it is present in a prokaryote and a eukaryote. So there you can start writing your differences. And in the end of the class or in the end of this chapter, we'll do a tabular differentiation between prokaryotic, eukaryotic cell. This will be one differentiation, and second differentiation between plant and animal cell. So each cell organelle that we will be talking about or discussing, I will keep on telling you the differences also then and there. Okay. Any doubts so far, anyone? Okay. So before I move on to plant cell, animal cell, I don't want to go into plant cell, animal cell right now. I want to talk about the cell organelles, like I said before. So I want to talk about the cellular organization as to how you can, when we are talking about organelles, how can we understand the organelle? So I'm just going to write down just going to share my whiteboard real quick. And I'm going to tell you about how we can remember the different kinds or different types of cellular organization that we have. Is my whiteboard visible to everyone? Yes, no. It would be really nice if I could get some answers. Okay. All right. So if I want to tell you about cellular organization and how to remember it easily. So cells can be divided, or it can be divided, we can, the organization can be divided into two parts. So we have the cellular envelope and we have the protoplasm inside it. So anything that is present inside the plasma membrane is the protoplasm, and that will be living. Cellular envelope can be two types. We have the cell wall and we have the cell membrane. Okay, this is just my way to remember certain things. So you can note it down, or when we come to the regular classes, I'll do this much more in detail. Protoplasm is what? Protoplasm is nucleus plus cytoplasm. So this will also help you to understand the different terminologies that are used in books, textbooks. Okay. Cell wall is the outermost covering in most of the organisms. So it is present in plants. It is present in bacteria. It is present in fungi. And it is made up of usually derivatives of sugar. Okay, so different organisms have a different cell wall, but all of them are derivatives of sugar. Okay, so for example, plants, we have cellulose, bacteria, we have peptidoglycan, fungi, we have chitin. So they're all made up of sugar molecules. Cell wall is a dead component. Since it's simply made up of a biomolecule, it is not living. Okay. Then comes the cell membrane. Cell membrane is present in all living cells. So whether it's a plant, bacteria, fungi, animal, all of them will have a cell membrane, and it is the living component. So now everything inside the cell membrane is the protoplasm. Cytoplasm is simply everything minus the nucleus. Okay. Nucleus will be the control center of the cell. Okay. And it will have the genetic material. Cytoplasm, on the other hand, is made up of cytosol plus all your organelles. So cytosol is nothing but cytoplasm minus all the organelles. So we have like different organelles, mitochondria, ER, Golgi, all these things are present, and whatever remaining liquid matrix that we have is the cytosol now, where you have enzymes and ions and water and everything. So we have different types of organelles. We will have the mitochondria, we have plastids, we have endoplasmic reticulum, Golgi, ribosomes, etc. So we will talk about each one in detail. We'll start with this and then we'll go on to the cell wall, cell membrane, and then move forward. Okay, so one by one, we'll discuss this when we come to the regular classes. So this is just an overview of what is a cell. This will also give you an idea of what is the difference between a protoplasm, cytoplasm, and a cytosol. Okay, any doubts so far, anyone? Yes, no? Okay. All right, so I'm going to stop here. All right. I hope to see you all in the regular classes soon, and we will begin with the syllabus whenever ma'am is done with your ER stands for endoplasmic reticulum. Yes. So whenever Usha ma'am is done with physics and chemistry, only then I'll be seeing you. So probably in the end of the sessions. Okay. So I hope to see everyone in the regular classes soon enough. Okay. So I hope you enjoyed yourself with both the demos, and I'll see you soon. Bye, everyone. Thank you for joining.